Okay, so in the last video we learned that parallel lines have the same slope and perpendicular lines have slopes that are opposite reciprocals. So now we're going to apply that to writing equations using parallel and perpendicular lines. So what if you are asked to find the equation of the line that is parallel to this one, y equals 2/3 x subtract 8. But it goes through the point 3, -1. Now you could look at this graphically. You could take a piece of graph paper and you could plot the equation y equals 2/3 x minus 8 by plotting the y-intercept and using the slope to graph more points. I would have to make this much longer though. Alright, so remember how you do this now when it's in slope-intercept form? It's in y equals mx plus b form. You graph the y-int, which is 0, -8. So 1, 2, 3, 4, 5, 6, 7, 8. Here's my y-int. Then you use the slope, which is going to rise 2 and run 3 to add more points. So from the point 8, 0, 8, you rise 2 and run 1, 2, 3. You rise 2 and run 1, 2, 3, and so on and so forth, so you get enough points on it. So there's my first line. I've barely begun this problem because my next task is to go back to the directions which said write an equation that's of a line parallel to this, but it goes through a different point, 3, -1. It has to, because it can't go through any of the points this line goes through, or they wouldn't be parallel. So what I'm going to do is I'm going to graph that point. The point was 3, -1. 1, 2, 3, -1, right there. So I want a line that's parallel to this one, but goes through that point. Well, I could just kind of take my ruler and kind of guess what that's going to look like, but remember they have to have the same slope. So if I apply my slope, which was 2/3, by rising 1, 2 and running 1, 2, 3 from this point, and then I can do that backwards, drop 2, go 3 backwards, just so I'm getting points all on a line that between each point I would rise 2 and run 3, rise 2 and run 3. I will have the line that's parallel to this one, whose equation was y equals 2/3 x minus 8, but goes through the point 3, -1. So it's a whole different line, and we want to write its equation. Well, we already know it has to have exactly the same slope as this one, because parallel lines have the same slope. So we know it's going to start with y equals 2/3 x. So what else do we need? Well, all we need is the y-intercept, which, by adding more points from the point given that it goes through, I was able to run into my y-axis, and it looks like that y-intercept is -3. That's the graphical method. And again, just like the last graphical method we learned, it works just fine as long as that y-intercept is an integer or a whole number, and that's not always the case. So we do need a calculating method of doing this, and that's what I'll show you next.